Hey everyone, in today's lesson we're going to talk about special trinomials. These are trinomials that have quick steps to factoring, and so you can factor a little bit faster and expand a little bit faster once you get the hang of it. All of the usual factoring methods that we have done previously will work on these trinomials, but these are just faster ways to do it. The first type of special trinomial we're going to talk about is a perfect square trinomial. A perfect square trinomial is one where the factored form is a square, and so you can see here I have gone through and factored x squared minus 6x plus 9. I factored that I looked for two numbers that multiplied to positive 9 and added to negative 6. Those two numbers were negative 3 and negative 3. And when you have something times itself, you can write it as a square, which is why I have squared it. That is where the perfect square trinomial comes from, where the name comes from, because we have something squared, and that is going to give us our final form. Now, how can we check right off the bat if we have a perfect square? So just given the question, how can I go backwards? The very first thing that I need to ask myself, is A a perfect square? In this example, A is just 1, and I have an x squared. 1 is a square, x squared is a square. So yes, I'm good. Then I need to say, is C a perfect square? So I'm going to look at C. 9 is a perfect square, so I'm good. Step number 3 is a little bit more complicated. I need to look at B divided by 2. So in that case, 6 divided by 2, which is 3. Is it equal to the square root of A times the square root of C? So remember, A was 1 and C was 9. The square root of 1 is 1. The square root of 9 is 3. 1 times 3 is 3. So this part of my equation is 3. Then I need to say, is 6 divided by 2 3? 6 divided by 2 is 3. 3 is 3, and therefore this is all good to go. It'll take a little bit of time before you get into the pattern of checking this, but hopefully you'll get it down soon and easy. Let's look at some examples here. X squared plus 14x plus 49. I'm going to check my three things. First and foremost, I need to check to see if x squared is a perfect square. Remember, there's just a 1. That's good. Then I need to check to see, is C a perfect square? 49 is a perfect square. Check. Now I need to see, is B divided by 2 the same thing as root A times root C? B divided by 2 is 14 over 2 because B is 14. Let's check to see if that's equal to the square root of 1 times the square root of 49. 14 divided by 2 is 7. Root 1 is 1. Root 49 is 7. 1 times 7 is 7. So we are good. This is a perfect square. Let's do another check. I need to see, is A a perfect square? I have 9x squared. 9 is a square. X squared is a square. This is all good. Then I need to see, is 16 a square? Yes, it is. 16 is a perfect square. And finally, I need to check if 24 over 2 is the same thing as root 9 times root 16. 24 over 2 is 12. The square root of 9 is 3. The square root of 16 is 4. 3 times 4 is 12. Once again, another perfect square. Final example here, x squared minus 12x plus 36. First things first, x squared is a square. 36 is a square. I need to do 12 divided by 2 is equal to, is it equal to root 1 times root 36? 12 over 2 is 6. Root 1 is just 1. Root 36 is 6. 1 times 6 is 6. So this is all good. I've included this third example here to point out the fact that this is a subtraction sign instead of an addition sign, as we saw in the first two. A subtraction sign doesn't make a difference when you are doing this third level check, okay? At the end of the day, it'll be rather easy to do, and we'll see in the shortcut what that means for us. So let's talk about the shortcut to factor a perfect square. So if I have a squared plus bx plus c, I can factor that. I can take the square root of a squared, okay, so the square root of a squared, those match up. And I need to take the square root of my c term. And because I am dealing with addition, my b is positive, I'm going to have an addition sign in between the two. Okay, now that's going to be the exact same thing if it is a subtraction sign. So we have an a squared, we need to take the square root of that. C, we need to take the square root of that, except if it's a subtraction sign, if b is negative, then it's going to be a negative in between. Okay, let's look at an example here. So I have x squared minus 6x plus 9. Okay, let's go ahead and factor that. So I'm looking for, I know it's going to be a minus sign in the middle because it's a subtraction sign here, so I'm going to put a minus squared. I need to take the square root of all of my stuff in the first term. The square root of x squared is x. So I'm just going to I'll do the square root of x squared. And then I need to take the square root of 9 because that is my c. So this will give me the square root of x squared is x minus the square root of 9 is 3, x minus 3 squared. Let's look at our next example, 25x squared minus 90x plus 81. Okay, again, I'm looking for two terms squared. They're going to be subtraction sign in the middle. I need to take the square root of my first term, so 25x squared, and I need to take the square root of my second term. Okay, the square root of 25 is 5, the square root of x squared is x, minus the square root of 81 is 9, and the whole thing is squared. Let's do our last example here. 9x squared plus 48xy plus 64y squared. Okay, again, I'm looking for two terms. This time it's going to be a plus in the middle because it is a positive b. I need to take the square root of a, so the square root of 9x squared. And then I need to take the square root of c, which is 64y squared. The square root of 9 is 3. The square root of x squared is x, plus the square root of 64 is 8. The square root of y squared is y, and the whole thing squared. And so that's that for perfect square trinomials. And remember, perfect square trinomials, you're always going to end up where your solution is a binomial term and then squared at the end of the day. That is the key feature of a perfect square trinomial. Let's take a look now at our second type, difference of squares. And a difference of squares, there is no middle term, there is no b term. And let's look at why that happens. So we have, for example, 2x minus 3 times 2x plus 3. Well, if I go ahead and expand that, I'm getting 4x squared minus 6x plus 6x minus 9. We can see here that we have a negative 6x and a positive 6x. Those cancel out, and so what happens, there's no middle term because the two middle terms, it's just a middle term of 0. They cancel each other out. And so we are left with 4x squared minus 9. There's an invisible b value of 0 here. These are really easy to check to see if you have one, okay? First, we need to just check to see if a is a perfect square. So is 4 a perfect square? Yes, it is. Is C a perfect square? Yes, it is. And finally, is there a subtraction or a difference between them? That's how it's called a difference of squares, because it is one square minus another square. In this case, we do, yep, it's easy to go. It's very easy to factor. And as you can see with our shortcut to factoring here, so if I have ax squared minus c, basically I take the square root of my ax squared and the square root of my c, and I have two terms that are identical except one has a plus and one has a minus. The plus minus will result in this happening in the middle, and it becomes 0, and then you're good to go. So it's the square root of a squared plus the square root of c times the square root of a squared minus the square root of c. Let's take a look at some examples here. Okay. First one, x squared minus 121. Okay, we take the square root of our first term, which is x, and the square root of our c term, which is 121, that's 11. So I'm going to do x plus 11, x minus 11. Okay, let's look at our next example here. 9x squared minus 100. Okay, so we know we're looking for two brackets here, one with a plus, one with a minus. The first term in these brackets is the square root of my a. So I need to take the square root of 9, which is 3, and the square root of x squared, which is x. Then for my second term, I need to take the square root of 100, and that's 10. Okay, so my final answer is 3x plus 10, 3x minus 10. Let's do another example here. 25x squared minus 49y squared. Okay, remember we're going to set it up here. Two brackets, one with a plus, one with a minus. To find my first term, I need to take the square root of everything here. So we'll do the square root of 25 is 5. The square root of x squared is x. Then we do the square root of 49 is 7. And the square root of y squared is y. So my final answer here is 5x plus 7y times 5x minus 7y. Okay. We have a bit more of a complex problem here. Negative 48x squared plus 75. Remember, in order for this to be a difference of squares, we need the subtraction sign to be in the middle. So the very first thing that I'm going to do is I'm going to rearrange this problem and switch the terms. So I have my 75 first, and then I have negative 48x squared. And so we can start to see we're following the right format. But 75 is not a perfect square, just like 48 is not a perfect square. So we need to see what can be factored out, common factored out, in order to make this a difference of squares. And this is your first introduction to combination factoring, where you need to use more than one strategy in order to factor. Okay, now if we factor out a 3 from both of these terms, let's see where that lands us. 75 divided by 3 is 25. 48 divided by 3 is 16. And look, now we have our perfect difference of squares that we can work with in the middle here. I'm going to leave my 3, and once again I'm having two sets of brackets, one with a plus sign, one with a minus sign. This time, instead of x being first, x is actually in our second term, and that's fine, doesn't matter. Still follows what we need it to, where it's two squares and a minus sign. First we'll do the square root of 25, which is 5. Then we'll do the square root of 16, which is 4. And the square root of x squared, which is x. Okay, so again, this is an example where you have to common factor first, and then you can use your difference of squares. Let's look at our last example here. 36 minus x minus 4 squared. Okay, so this is pretty straightforward because we have a difference of squares. 36 is a square. X minus 4 squared is also a square because it is being squared. So we can follow this as if it is a perfect difference of squares, even though it looks a little weird. We've got a bracket here. Remember, I'm looking for a plus and a minus. I'm going to get my first term by taking the square root of 36. The square root of 36 is 6. And then I need to take the square root of x minus 4 squared, which just gives me x minus 4. Now this can be simplified even further. I'm just going to rewrite it without any brackets. 6 plus x minus 4, 6 minus x plus 4, because a negative minus a negative is a positive. I'm going to go ahead and rearrange this, so I have x and then a 6 and a negative 4, so x plus 2. 6 minus x plus 4. We'll do 6 plus 4 is 10 minus x. So even though we're not landing in the exact same format that we had before, we used the difference of squares principle and rule in order to help us factor much more efficiently. Imagine if you were to actually write this out, and if you expanded this first and then you tried common factoring or group factoring, just how long it would take you versus doing it this way, and we landed very quickly right at the conclusion. Okay? And that's about it, folks. So that was for difference of squares and perfect square trinomials.